Prep 2, today we start lesson 3, main groups of the modern periodic table. We are going to talk about 3 main groups, and as we know from the previous sessions that group is a vertical column found in the modern periodic table, and the modern periodic table has 18 vertical groups. We will take only 3 groups and study them. Number 1, group 1A, alkali metals, group 7A, halogens, and the group 0, which contains noble gases. In each group we have to know, number 1, the location in the modern periodic table, some physical properties of elements found in this group, and some chemical properties of elements found in this group. Group 1A, alkali metals. 1A, it contains lithium, sodium, potassium, rubidium, cesium, francium. The location of this group is found at the maximum left side. It is the first group, group 1A, so it's found at the maximum left side of the modern periodic table in S block. Number 2, the physical properties. They are all solid in room temperature. Any element of this element is solid at room temperature. Number 2, they have metallic luster, they are shiny. Number 3, they are good heat and electric conductors, as we know that metals are good heat and electric conductors. Most of them have low density, so they float on the water surface. Lithium, sodium, and potassium float on water surface. Give reason: because they have lower density than water density. Rubidium and cesium sink in water. Give reason: because they have higher density than water, so they sink in water. This is an example. Element A and element B. What do you expect for element A? Element A may be lithium or sodium or potassium. Why? Because it floats on water surface, and once it floats it has lower density than water. Element B may be rubidium or cesium. Why? Because it sinks in water. Give reason: lithium and sodium float on water surface while cesium and rubidium sink in water, because lithium and sodium have lower density than water, so they float, while rubidium and cesium have higher density than water, so they sink. I have an atom to study the chemical properties. Number 1, any element found in group 1A must have 1 electron in the outermost level. So all the elements found in group 1A, all the alkali metals of group 1A have 1 electron in the outermost energy level. Number 2, they are monoatomic elements. What's meant by monoatomic? When I bring sodium element, I write Na, only Na, not Na2 or Na3. No, only Na. So they are called monoatomic elements. The element of alkali metals is formed of only 1 atom. As each element of 1A group is formed of only 1 atom, number C, they are monovalent element. Monovalent, monoatomic. What is the difference between monoatomic and monovalent? Monovalent means that they tend to lose 1 electron during the chemical reaction. As we said before, lithium is one of the alkali metals found in group 1A. Lithium Li3, electronic configuration 2, 1. Loses 1 electron. Why? To be more stable, to be like the nearest preceding inert gas. Okay, so any element found in group 1A, it has 1 electron in the outermost level. It's a monoatomic element, and it tends to lose 1 electron during the chemical reaction. Number D, they are chemically active. They are chemically active, so they are kept under kerosene layer. What's meant by chemically active? If I have a piece of sodium, it's shiny and it looks silver, silver color. Okay, when I lift it or when I leave it on the table for about minute, 2 minutes, 3 minutes, it starts to be black. Why? Because oxygen of air reacts with sodium, so it reacts very fast. They are chemically active, so they are kept under kerosene, not in the air. Why? To prevent their reactions with oxygen of air, like this. When we store lithium, sodium, or potassium, we put it under the surface of kerosene. Why? To prevent the air from reaching these elements, because they are very active. E, they react with water forming alkaline solution. You have to ask me, why did we say that metals of group 1A are called alkali metals? Why they are called alkali metals? Because when they dissolve in water or when they react with water, they produce alkaline solutions that turn litmus into blue color. 2Na plus 2H2O, 2NaOH. NaOH is acid or base, and it turns litmus into blue, and the hydrogen gas evolves. F, form up to down, from up to down. As the atomic number increases, the atomic size increases, as we studied before, and the chemical activity increases as well. That's why potassium is more active than sodium. Why? Because when we move from up to down, the chemical activity increases. Give reason. The reaction of potassium with water is stronger than the reaction of sodium with water. Why? Because potassium has larger atomic size. Potassium is found below sodium, so it's more active. Why? Because it's bigger. Note, francium, the last element, is radioactive element. What's meant by radioactive? Element that is not stable. When I leave a piece of francium on the table, after an hour or two, or maybe less or more, it starts to be decomposed, to disappear into rays. Okay, that's what's meant by radioactive element. Give reason. Alkali metals are kept under surface of kerosene to prevent the reaction with oxygen of air. Cesium is the strongest metal because it has the largest atomic size. Elements of group 1A are called alkali metals. Why? Because they react with water forming alkaline solution. 2K, for example, plus water produces potassium hydroxide alkaline solution, and the hydrogen gas evolves. That's why K is an alkali metal, because it produces alkaline solution. Hydrogen is not an alkali metal. Group 1A starts from hydrogen to francium, but why not hydrogen is not considered as an alkali metal? Why it's a non-metal? Because hydrogen is gas, so it's a non-metal. Okay. Group 7A, the second group with us. 7A contains fluorine, chlorine, bromine, iodine, astatine. The location, it's located at the right side just before zero group. Okay. I have one of the halogens right here to start to study the chemical properties. Fluorine. The chemical properties, they have 7 electrons in the outermost level. The outermost level is L. How many electrons? 2, 4, 6, and 7. Number 2, they are diatomic elements. What's meant by diatomic elements? The monoatomic elements in the alkali metals, they are formed of only one atom. Sodium, one atom. Potassium element, one atom. But here, when I say fluorine element, I have to bring 2 fluorine atoms together, or 2 chlorine atoms, or 2 bromine atoms. Number 3, they are monovalent elements. How come? Fluorine, the electronic configuration is 2, 7. Gains how many electrons to complete this level? Only 1. Gains 1 electron. 2, 8. How many electrons are gained? 1. It's a monovalent. And the rest of group 7A, the rest of the halogens are monovalent as well, as they all have 7 electrons in the outermost level, so they gain only 1 electron. They react with metals forming salts, and that's why they are called halogens. When I ask you, give reason, halogens or elements of group 7A are named halogens because they react with metals forming salts. I have a metal, potassium, and halogen, bromine. Why bromine is Br2? Because they are diatomic molecules, diatomic elements as well. Okay. Produces potassium bromide, which is salt. I have another example, potassium and iodine. Potassium is a metal, iodine is non-metal from the halogens. produces potassium iodide, salt as well. Sodium and chlorine produces table salt or sodium chloride. Sodium is a metal, chlorine is non-metal, and halogen as well. Each element replaces the below in its salt solution. If I have a salt formed of metal and halogen, okay, other halogens may replace this halogen in this salt. How come? I have a salt, potassium bromide, metal and halogen, okay, and the chlorine is a halogen as well. Chlorine can replace bromine and takes its place. Why? Because chlorine is stronger than bromine. It's found upper than bromine, okay? So chlorine can replace bromine or iodine or astatine in their salts. Another example, bromine plus KCl, potassium chloride, no reaction. Why no reaction? Let's check. Chlorine is found at the second square and bromine below. Bromine can't replace the upper. Only the element replaces the below in their salt solution. So chlorine can replace any element below. Bromine can replace iodine and astatine. But can bromine replace chlorine? No, it's not right. So when I ask you what happens when we add bromine on salt or potassium chloride, simply no reaction. Why? Because bromine is below chlorine, so it can't replace chlorine. What happens when we add chlorine gas, okay, on sodium iodide solution? Let's check. Chlorine and sodium iodide. First question, chlorine is above iodine or below? Chlorine is above, so it can replace iodine. Chlorine takes the place of iodine, producing sodium chloride, and iodine comes out. Properties and uses of some elements. I have 4 elements and I want to know the use of each of them and why this element is used. Number 1, liquid sodium, radioactive cobalt, and we said before that radioactive is an element that produces rays, okay? Silicon, liquid nitrogen. 4 elements, I want to know the use of each of them, okay, and why they are chosen for this usage. Liquid sodium, it's used to transfer the heat from inside the nuclear reactors to outside. Give reason, because it's a good heat conductor. So if I have nuclear reactor and the nuclear reaction occurs inside it and a lot amount of heat is produced, I can transfer the heat from inside the reactor to outside by using liquid sodium, and then I can use this heat to produce electricity. Radioactive cobalt that produces rays. It's used in food preservation. Give reason, because it produces what? Gamma rays. Why it produces gamma rays? Because it's radioactive. Because it produces gamma rays that prevent the microbial reproduction. If I have a food in a factory and I want to make sure that no more bacteria is present in this food to prevent rotting of this food, I can use radioactive cobalt as it produces gamma rays that prevent the microbial reproduction, the increase in the bacteria. Like this, I have a strawberry. By using gamma rays, bacteria dies. Silicon, Si14. Silicon slides are used in manufacture of computers. You know the motherboard found inside the computer or found inside our mobile phones may be made of silicon. Why? Because silicon is semiconductor, as it conducts electricity according to temperature. Liquid nitrogen. Liquid nitrogen is used to preserve the cornea of the eye. Why? Because it has very low boiling point, equal -196 Celsius degree. And thank you for watching.